Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 83 of physics. Today we are going to start unit number 14, and in other words you can say that we are going to start topic number 14, and that is reflection and refraction of light. Very important topic as far as physics is concerned. uh, if you look around you, you may be able to name a number of image forming devices: the camera, the overhead projector, the video camera, the microscope, spectacles, various type of mirrors, the photocopying machine, and others. We live in a society where we make use of such devices frequently. What features do all these devices have in common? What ideas in physics are used in these devices? In this topic, we will study some of these ideas. So, let us first see that what is the nature and how the light is propagating. In this regard, first we will understand that what is light. Now, as you learn from the previous unit, that electromagnetic spectrum contains a small portion of visible light. That visible light can only be detected by the human eye. That is a very small portion of electromagnetic radiation, electromagnetic wave spectrum. Uh, in this regard, we define light as that part of electromagnetic spectrum that can be detected by the human eyes, as we saw in the diagram of electromagnetic spectrum. Our human eye detects light in a range of colors from red to orange to yellow to green to blue to indigo and to violet. Remember, dear learner, if you want to remember all these colors, then you have to memorize this Web where V stand for violet, this I stand for indigo, this is blue, green, orange, yellow, and red. Now, if you see the traffic lights, they are showing you this red, yellow, and green because their wavelengths are larger, so they can be seen far away. So that is why these color are used. No black color is there and no violet color is there because they cannot be seen from distance. So human eyes can only detect these 7 colors. When these 7 colors are combined together, they are making a white color. They are making a white color. Ladies and gentlemen, let me ask you a question. And the question is that why we are seeing the sun as a red one when it is rising or when it is sinking down, and why we are seeing the sunlight as a bright white when it is above our heads. Why? Ladies and gentlemen, the answer of this question is we are seeing it because the axis of rotation is in elliptical shape. If we are here, so whenever the sun is going away from us, then only red color can be seen because the wavelength of red color is the greatest one of all these visible light. So that is why red color can be seen when it is sinking down or when it is raising up. So in these both cases, the sun, all seven colors, is only conveying red color to us because it can be seen from a distance. Uh, Now, in the case of white light, when it is here above our head, then all seven color combinedly at one time can reach to our eyes, and as a result we are seeing it is a white light. So this is the reason when all the lights in this seven colors which is coming from the sun, in fact there are many other colors but that cannot be detected by the human eyes. So that is why we are saying these seven colors are only detectable by our eyes. When all these seven colors are reaching at the same time to eyes, it means that we are seeing a white color. So in this way we can see the seven color. Our human eye detects light in a range of colors from red to orange and until violet. When these seven colors are mixed, they form white color. Yes, that is what I told you. The second property you must have to understand is this. Second one, light travels in a straight line called rays. Dear learners, if I want to explain this to you people, then because light is traveling in a straight line, it will never go to the object, it will never reach to the object in color light. So this is known as the ray. So they are always going in straight line and now not in this type of curved line. Each of this is called ray, but remember, dear learners, that there is no such arrow like thing in the light. This is just used for representation. In fact, the particles of light is moving in a straight line like this, so we are showing it by an arrow in straight line. But don't consider that there is a ray just like the arrow. No, nothing is there. So light travel in a straight line, and for that I want to show you a figure, which is this one. There is a sun in which light rays are emitting in every direction. You can see that all these rays are denoted by the arrowhead, and when they are coming towards the eyes, one thing more, here I must explain that don't expose your eyes to the sun, because ultraviolet rays are coming from the sun and they can damage your eyesight. So never expose your eyes directly to the sun. So if you can see that these rays are coming in straight lines and there is arrowhead there, but no such arrowhead is available when we are seeing it in practically. This is just the demonstration of light rays travel in a straight line. One thing more I want to tell you, that if light rays were not traveling in the straight line, we won't be able to see the shadows. If they are creating the shadow, then it means that it is propagating in a rectilinear way from the sun to our eyes. One thing more, that when the rays are combining together, they are forming a beam. They are forming a beam of light. So what is beam of light? The combination of different ray. The combination or the bundle of rays is called what? A beam. So let us discuss this property, that the figure you are seeing right now, in which there is a sun and eye, shows light energy from the sun traveling to the eye in straight lines called rays. What do we mean by a ray of light? We often get the impression that we can see rays of light in a dusty room or a cloudy atmosphere. This impression is caused by the scattering of light by the suspended dust particle in dusty room or water droplets in cloudy atmosphere. Dear learners, if you can see in this picture, there are rays of light in it, and there is also water in which we can see the moonlight. So the droplet of that water is reflecting the light. Now in case of dusty room, there are particles in the room. When the light, which is also composed of particles, there are two types of lights. One is having particle nature and one is having the wave nature. So when the particle is striking the dust particle. That ray is reflected to our eyes, and as a result we can see the dust particle in the room, and we are having that we can see that we are seeing the light. Actually, you are seeing the reflection of light through those dust particles. Uh, the idea of a ray is an idea invented by scientists. Whenever you see the word a ray of light, they refer to the line along which the light travels, uh, through which the light travels. Light rays in reality do not come in the form of arrows. Arrows are drawn on diagrams to represent the direction in which light travels. A bundle of rays is known as a beam of light. The figure you are seeing at the right bottom at your screen right now shows three different types of light beams. There are three types of light beam. So I discussed with you that there are three types of rays which can be seen. The number one part is called parallel beam. Now parallel beam of light is that light in which every ray is going in a straight line and they will never meet with each other. The second type of ray which is observable is convergent being. When rays are meeting at a point, in this case, this is the point where they are meeting. They are converging to a point. We will discuss that in greater detail in the next topic, that what is the convergent lenses and divergent lenses. In third case, they are calling us divergent beams. When rays are spreading out from a particular point, just like from here in different direction, as you can see from the sun here as well, they are going in different direction, so they are diverging. In that case, here it is converging. In this case, they are moving toward a focus point, or they are diverging, spreading out from a point. So there are three types of rays available as far as light rays are concerned. Because light rays are traveling in a straight line, so we are saying that there are three type of rays. Okay, that was the basic concept of rays. Now we are coming towards the mainstream, and that is the main motto of this topic, to discuss light rays and reflection. The name of this unit is reflection and refraction. So in first part of this unit we are studying the reflection of light rays. Uh, First of all, before the reflection, which we defined in the previous unit the bouncing back of light to the eye from an image is called reflection. In tomorrow's lecture, we will discuss that there are uh, two different types of reflection available. But first of all, let us understand that what is luminous and non-luminous object. Now, luminous is a word used for lighted, enlightened, and non-enlightened object. Dear learners, these are two very important concepts. Then we will move towards the laws of reflection. But first, let us understand that any object such as the sun, a lighted candle, or a bulb that gives out light on its own is called a luminous body. The bulb is a luminous because it is giving us the light. The sun is a luminous because it is also giving us the light, and similarly the candle as well. Conversely, any object such as a table, a wall, or picture that does not give out light on its own is called a non-luminous body. For example, in the figure, you can see that there is a picture on the wall and there is a filament lamp in the room. The rays are directly coming from the luminous object to this non-luminous object. And then we can see that object when it is directed to our eyes. We cannot see these objects if there is no light. In the dark room, you cannot see anything on the wall or any other area. In fact, we won't be able to see the bulb as well if there is darkness in the room. So the luminous object can be seen directly by the eyes as well. This eye can detect the luminous object because rays are coming to the eyes, and that eye can detect that filament lamp bulb. The picture on the wall can only be seen if light is reflected from it and directed to our eyes. So in this case, we can only see that the picture on the wall which is shown in the figure, that how the eye sees a lighted lamp, a luminous object, and a picture, a non-luminous body. In the figure, the eye sees the filament lamp due to the light emitted by the lamp entering the eye directly. As for the picture, the eye can only see it by means of light reflected by the picture entering the eye. If the lamp is switched off and the room is completely dark, the picture and of course the unlit lamp cannot be seen as no light enter the eyes. This confirms the fact that the eye sees non-luminous object by the reflection of light. That is why we studied the reflection of light. Now we are coming towards very important two laws of reflection, and which is referred in the previous topic, and at that time I told you that I will point out to that topic, and that will be studied in the subsequent chapter. So today it is the time to study it. We learn what is reflection. So there are two laws of reflection. Before diving into the detail of those two laws, let us perform an experiment. And due to the observation from this experiment, we will do what? Then we will derive those two laws. The experiment name is to illustrate the laws of reflection. For this experiment, we need a ray box, which is this one. Then we need strip of plane mirror, which is this one. And plane mirrors are those mirrors in which we are dressing our hairs, seeing our faces at morning before going to school, colleges and offices. That mirror is this one, and that is called a plane mirror. We need a protector to measure these two angles. We will need a protector. And another thing, piece of paper, which you can see in this whole area as a white. So we have to draw these lines on the paper. Now the procedure, one number step is set up the apparatus. Set up the apparatus is shown. So we have to set up the apparatus like this. There will be a mirror and a ray box at an angle from which a ray will be directed towards the plane mirror. As you can see from this arrow, it will be directed to that, and after the reflection we will observe it on the screen. So that is the first part. The second part is vary the angle. We have to, in the second part, we have to vary the angle. So we are going to vary this angle. Sometime we have to move it in this direction, and sometime we have to move that in other direction. So in this way you will vary this angle. Now in the third part, compare the values of I and R. Here we have to compare the values of I, which is incident ray, and R, which is known as the reflected ray. This is R and this is I. So we have to observe these things. Now when we complete the experiment, careful observations of the experiment will show that for each value of angle of incidence I, the corresponding value of angle of reflection R is the same. Whenever you are measuring this angle with the protector and this angle with the protector, you will find that both angles are the same. If you are varying this angle, so it will also be varying. Then this angle and this angle will be the same. So keep these things in mind, that the incident angle and the reflected angles will be the same. Now, we can now summarize the laws of reflection as follows. There are two laws we can derive from the observation of these reflection. The first law, which is very important, you have to memorize and understand it. First law is saying the incident ray, the reflected ray, and the normal to the surface all lie in the same plane. If you are considering this is a plane, then this ray, normal, and incident ray all are in the same plane. It is not like this, that this ray will get out and out of the plane. No, all will lie in the same plane. This is the observation of this first law of reflection. Now, there is a second law of reflection that is more important than the first law. Because there are questions, numerical questions on these two laws, but mostly on the second law. Let's understand the second law. The angle of incident, which is denoted by I in this case here, the reflected ray, which is denoted by R here, the angle of incident is equal to the angle of reflection. Now, this is very important, that the incident and the reflected angles are equal, and mathematically we can write it that I is equal to R, means that incident ray angle of incident ray is equal to angle of reflected ray. And gentlemen, I'm afraid I have to stop it here because the time is not allowing me to go further. Tomorrow we will discuss very important topic, so be with me for that topic. Don't miss it. We have started the new topic, and if you are missing one part of the topic, then you will not understand the subsequent topic. Thank you very much for your time. Allah Hafiz.